All right, so like we said, for dissociation reactions for an acid, basically you just take off a hydrogen. So for this molecule, you're going to take off the hydrogen, so that's H+, and we got to write down whatever's left over. So if you take a H off of the acid, what you are left with is ClO4, and we need to write minus. And that's pretty much it. That's how you write the dissociation reaction for an acid. Just take off the hydrogen, whatever's left over, just make it negative. Okay? So when we take a look at acids and they dissociate, the key thing that I want you guys to note is that acids, they release one H plus at a time. So you guys don't need to write the example. I'll go over it in a second. But I do want you guys to write this in your notes because it'll be helpful. Acids release one hydrogen at a time. All right, so if we take a look at our example right here, let's take a look at this acid right here. This is our acid, H2SO4. And like we said, it releases a hydrogen, right? So do you guys see how H2SO4 is going to remove a hydrogen? And when you remove one hydrogen from this molecule, it becomes HSO4 minus. Okay. Again, the only difference is instead of two hydrogens, now it has one. Okay. Now this right here, since it has a hydrogen, can also work as an acid. So we're going to take it to the bottom right here. And this acid can also release a hydrogen. So we take off an H, and it becomes SO4 2 minus. So acids, they can have multiple ionizations depending on how many hydrogens they have. So this guy has two hydrogens, so it has a first and second ionization, which means it releases it twice. Okay. All right, so let's do an example with H3PO4. So on your paper, we're going to write H3PO4, and we're going to write the dissociation reactions for this acid right here. All right, so let me give you guys about a minute. See if you can do the first ionization. Okay, so you're going to take off one hydrogen from this acid. See if you guys can write that equation. And if you feel comfortable doing the second and the third one, you can do that as well. But we'll go over all three. But at least try to get that first one. So take off a hydrogen from this acid. Let's see what dissociation reaction you get. All right, so I put the answer up on the screen. Everyone gets something like that. You take off a hydrogen, and then you're left with H2PO4 minus. Okay, don't forget the minus sign. You're going to need to put the positive and negative charge for when they dissociate. Okay. All right, let's do the next dissociation. So now we can take this acid right here, H2PO4, and let me give you guys H2O4 minus, excuse me. And let me give you guys about a minute or two. I want you guys to do this dissociation now, the second one, and see if you guys can do the third one as well. So try finishing up the rest of the dissociation reactions. Alrighty guys, so this is how we get the dissociation reaction. Again, if you guys notice, same thing. Just take off a hydrogen every time. But the other thing I want you guys to keep in mind is if you take a look at the charges, every time you take off a hydrogen, it goes down by one, right? So just make sure you guys keep that in mind as well. Every time you take off a hydrogen, since each hydrogen is +1, you take it out, it just goes down by one each time. Okay. All right, so that's acids. Let's go to bases now. And bases, we read in the article last time that bases are substances that create OH minus ions in solution. Okay, so they create Me when you guys put them in water. So example right here, NaOH, you put it into water, it splits up into Na and OH minus. So similar to acids, the OH comes off. So acids release one hydrogen at a time, right? However, and I want you guys to write this down, bases, they release all of their OHs at the same time. So you don't have multiple ionizations like we saw earlier. For bases, they all come off at one time. So for example, if this compound right here, BaOH2, it has two OHs, right? So that means that when it splits up, it's going to make one Ba and two OH minuses. Okay, so just keep that in mind. If a base has multiple OHs, they all come off at the same time, and you just need to make sure to balance it and indicate that there's going to be two of these OHs. So just keep that in mind. They release them all at the same time. So for the first base, RbOH, again, you're similar to acids, you're just going to take off the OH. So you take off the OH, and if you remove the OH, we have it right here, that's minus. Whatever's left over is Rb, so we have Rb plus. So this is going to be the first dissociation reaction. Okay, again, for bases, just take off the OH, and then whatever's left over becomes positive. Okay. All right, for the second one, we said that all of the OHs are going to come off at the same time. And if you take a look at this compound right here, there's going to be 2 OHs. You guys see that? That's why we have the parentheses and 2. So that means for this molecule, we're going to have 2 OH minuses that come off. And the thing that is left over is Ca. Now, to balance out the 2 OH minuses, Ca has to be 2 plus. Okay? So that's going to be the charge on Ca. So those are your 2 dissociation reactions for those 2 bases. All right, so that's acids and bases. When we put them together, we have something called a neutralization reaction. Okay, so you guys don't need to write down everything. I'll tell you what's important. First, I want you guys to write down this term, neutralization reaction. And neutralization reactions is what happens when an acid and base, they react. So you put them together, and it causes something called a neutralization reaction. Just write that term down. You don't need to write the definition. And we're going to talk about what a neutralization reaction is. All right, once you guys write down that term, neutralization reaction, I want you guys to write down this right here, the generic equation, because this tells you what a neutralization reaction is, and this is what you're going to have to do for your assignment today. Okay, you're going to be writing the reactions, and this is what the equation looks like generically, and I'll show you guys how to plug in the chemicals into this. But a neutralization reaction is when you add an acid and base together, and when they combine, you always make water and a salt. And I'll talk about what that looks like, but just write that generic equation for now. All right, guys, so let's talk about how a neutralization reaction will work. So we have an example right here, and we're going to use this as our, our guide for writing neutralization reaction. So first, we have an acid right here. This is HCl. This is going to be our acid. And then we have our base, which is NaOH. Okay, and we're combining them together. Now, we said the first chemical that we're going to make when acid and base combine is water. And you guys probably heard that water is H2O, right? That's the formula for water. But we can rewrite water to something that'll be a little bit easier to work with. If you guys take a look, water has 2 hydrogens and 1 oxygen, right? So the way that we're going to write it for this unit is we're going to write HOH. Again, it's the same thing. 2 hydrogens and 1 oxygen. Now, the reason why we're going to write it like this is because if you look at an acid-base neutralization reaction, it makes a lot more sense to write it like this because what's going to happen is the hydrogen inside of your acid and the OH inside of your base, they are going to combine and they form water, HOH. You guys all see that? There's a hydrogen on your acid, the OH in your base, they combine to make HOH, which is water. All right, and then whatever is left over is going to combine to create your salts. And salt for this unit is not going to be like the salt we eat. Salt is anything that's made out of a positive and negative ion. So basically whatever's left over from the acid and base. So if you guys take a look, the acid, there's Cl, and the base has Na left over. Those 2 are going to combine to form NaCl. And that's going to be your salt. Okay, so keep that in mind. The salt can have a different formula, but you'll always make HOH, you'll always make water. Okay, and we're going to close off class the lecture by doing a couple examples just to kind of get you guys aware of how to solve these. But generally, it's always going to look like this. Acid plus base on the left side of the arrow is going to make water and the salt from the leftovers. All right, so let's do a couple examples and then we'll be done. Okay, so let's do number 4. So what we're going to do is we're going to try number 4 together, and we're going to be combining our acid, which is HBr, And we're going to be combining that with our base, which is KOH. Okay, so our acid and base. Okay, and I'm going to color code it so it's easier for you guys to kind of see what's going on the screen, but obviously you don't need to color code it. Just keep that in mind. All right, so we said that the first chemical that's made when an acid and base react is water. So we're going to make HOH. And the way that's going to work is the H from the acid and the OH from the base, they are going to combine. And so we're going to make HOH. So that's the first chemical we're going to make. Yes. Yeah, always water. Yeah, the first chemical will always be water. All right, the second chemical that's made is your salt. And the salt is whatever's left over. So H and OH combined. So what we have left over is going to be Br and K. Okay, and they're going to combine together. Okay, and so what we're going to make is we're going to make KBr. Yeah, you're going to want to put the positive ion first. I think we talked about this is like the beginning of the year, but K is +1 because it's balancing out the negative, so you always put the positive ion first. Yeah. Easy way to think about it, just put the base one in the front. Okay, and there you go, guys. That is your neutralization reaction between that acid and base. Pretty simple. Just take the H, react it with the OH, and then the K and the Br react together. Okay. Obviously, we're going to make it a little bit more complicated as we do more example problems, but that's the general idea. You will always make water, and you'll always make a salt from the leftovers. All right, so our acid is HNO3, and our base is RBOH, and they're gonna react. So again, we're gonna make water, so HOH, so H and OH from the acid and base. Okay, so the H from the acid and the OH from the base, they reacted together. So if you take a look at the leftovers, we have RB and NO3. And we're going to put the positive one first. The positive one is the one from the base. So we're going to put RB. And then our negative one is going to come from our acid, so NO3. So this is what you guys should get. Okay, so that's the neutralization reaction for that. Any questions? Okay, so let's take a look at the example that we just did. And what we're going to do is we're just going to label what the charges of these ions are because it'll help us with the more complicated examples. So let's take a look at H right here. Okay, what did we say the charge of hydrogen is? It's +1. Okay, hydrogen is always +1. So if you want to write that down, make sure you write it down. And we said that OH from a base is always -1. Okay, so just keep that in mind. The hydrogen from an acid is always +1, and the OH from a base is always -1. All right, and this is going to make sense because if we put them together in water, the hydrogen, the +1 from the hydrogen, is going to balance out the -1 from the OH, and that's how they balance each other out here. Okay. Now, all the molecules have to balance each other out, and so we can, based on that, we can figure out what the charge of the other ions are. So for your acid, we have +1 for the hydrogen. That means the rest of the molecule, NO3, this needs to balance that out, which means this is going to be -1. Okay, so NO3 is -1 because it needs to balance out the +1 from the hydrogen. Okay, so NO3 right here is -1. All right, and then the last part of the equation we need to look at is the RB from the base. It needs to balance out the OH, which is -1, so this also needs to be +1. So if you guys take a look at all the molecules, you guys see how they all balance each other out? It's +1, -1. Okay, that's kind of the concept we're going to take into the last type of problem we're going to look at. The molecules all need to balance each other out with their charges. Yeah. This one right here? No, not necessarily. So the ones that'll always be +1 is hydrogen. The one that's always going to be the same is hydrogen. This is from the acid. That's always +1. And OH from the base will always be -1. These are going to change now. And that's the reason why we're doing this. Okay. That makes sense though? Okay. So yeah. H from the acid always +1. OH from the base is always -1. All right. So with that being said, let's go on to the last example for today. And this is the one where we need to take into account the charges. Okay, so let's start by writing down the beginning of our reaction. We got H2SO4 for our acid, and we are going to be combining that with MgOH2. Oopsies. Actually, I'm sorry, guys. Let's change this reaction just to make it a... I think it'll be a better example if we do HCl. Sorry about that. Let's change this to HCl. My fault. So HCl and MgOH2. My apologies. So we're going to be combining HCl and MgOH2. Sorry about the last minute change. Alright, so before we start, let's go through the molecules and let's figure out what the charges are. The thing that we just did, whether it's +1, -1, and we'll also get some different numbers. Okay, so let's take a look at the charges. So if you guys take a look at our acid, what did we say the charge on the hydrogen always is? 1. So this is always +1. So let's label that. And let's look at the other one that we always know. We said that OH is always what? -1. But there's 2 of them. Yes, that's what I was trying to get to. So there's 2 of them. So we got to take it into account. This is -1 and -1. Okay? Yes. No, because they're all individually -1. Yeah. All right. So let's take a look at the other parts of the molecule now. So if hydrogen is +1, what does Cl have to be? -1. Good. Nice. Too easy for you guys. All right. So that's +1, -1. They balance out. Let's take a look at the last part now, the Mg. Now Mg, if you take a look, there's only one Mg, right? And it's balancing out the 2 OHs. So what does Mg have to be? +2, exactly. Okay, so we're going to label that. Okay, so we just got to keep that in mind before we do our equation. Okay, so let's write the neutralization reaction now. We said that the hydrogen from the acid is going to react with the OH from the base. Okay, so we're going to make our water. We're going to make HOH. All right, so that's going to be our water. Now we have to make our salt. So if you take a look, the other parts of the equation are Mg, and that's going to react with the Cl. Okay, so we're going to write MgCl. Okay, but let's take a look at the charges. If you remember, Mg is +2, right? And Cl, if you take a look, is -1. So how can we balance out the Mg and the Cl? Yeah, you're going to need to add another one of the Cl's, right? Because you need 2 of these to balance out the 1 Mg. So this is going to become MgCl2. Okay? And that's the reason why we went over the charges, to figure out what kind of salt we're going to make. It's going to be MgCl2 because you need 2 Cl's to balance out the +2 on the Mg. All right, make sense? Okay. All right, there's one last thing that we need to do, and we got to balance it. Okay, but this is very easy to do. You guys don't need to do the table for this. I'll show you guys the easy way to balance it for this reaction right here. Okay, so the easy way to balance it is by just taking a look at the parts that are in the molecule. Okay, so let's take a look at the one that has multiple. So if you take a look at the left side, you guys see how there's two OHs, right? And if you look on this side, there's only one. So what we got to do is we got to balance it. So we're going to put a 2 right here. That way we can have 2 of these OHs. Okay, so that part is balanced. So far, so good? Okay, now, if we put a 2 here, now we have 2 H's on the right side. We need 2 on the left side. We put a 2 right here, and that's going to balance our H's. And then lastly, there's 2 Cl's now, which is perfect because we got 2 Cl's right here. So the super easy way to balance is just by looking at which one has multiples. We saw there were 2 OHs, so we put a 2 here to balance that out. We balance out the H's, and then the Cl's balance out that way as well. Okay. Now, if that's confusing to you and you want to use the table, just use the table. Do what's easiest for you. But that's a simple method you guys can use to balance out the equations.